So now we're going to move to a few equations that I know some of us are going to be like, oh no, because there's fractions. But don't worry, we're going to learn some strategies to help us work with fractions and deal with them. And later we'll start looking at some a little bit more complicated equations with fractions. But we'll keep them a little simpler for now. Now there's a couple ways you could deal with these. I'm going to show you two ways for A, and then we'll just maybe finish B together with one way. First of all, you probably recognize this looks like something that can be backtracked, and you're right that you could do that. And if I were to backtrack, remember this says a number times 3/5 minus 1 ends at 14. This is our ending number. So in order to backtrack that, I'd add 1 here, and I'd add 1 there, and it would leave me with 3/5 x equals 15. And at this point, I like you to think about using your reasoning with fractions, or your proportional reasoning too, because what we're saying is 3/5 of some number I don't know is 15. 15 is 3/5 of something. And you could certainly continue thinking about just like dividing both sides or something, but fractions are weird when dividing, and I think a lot of students I find kind of forget those fraction rules. And I think it's better to make sense of the fraction anyway. Now, if you think real carefully, if we were to split 15 into, if we were to think of 15 as 3 parts of something, remember 3/5 means 3 parts of something that's been split into fifths. If we think of 15 as being in 3 parts, how much is each of those parts? 5, right? Right? 15 is 5, 5, 5. And so, if we think of 15 as 3/5 of something, that means whatever that thing is needs to be fully 5 parts, which would be x equals 25. So you could think that through in your head. Another thing that's really helpful for people to remember is there's one fact that's very helpful about fractions, and that's the idea of reciprocals. And I'll show you something here. If there's a fact that's really important about reciprocals, when you multiply a fraction by its reciprocal, or any number by its reciprocal, it always equals 1. Because watch what happens. When you multiply this and this, it becomes 15 over 15. And that's just 1. And we know 1x is just x. So in this case, this becomes 15 over 15x. But if I multiply that there, I have to do it on the other side, because I can't lose that balance, right? And I get 15 over 15x equals 15 times 5 over 3. Don't forget that this can simplify and become 5 and 1. 5 times 5 is 25. And if that's 15 over 15, that's just equal to 1, and we get x equals 25. Okay? So that's one way. That was backtracking, right? So we just backtrack and we use our reasoning to think through in the end how the fraction works in. But there is a way that I find very helpful, and a lot of students really like it, that we'll look at right now. So let's take a look at that, and we're still going to get the same solution here. So going all the way back here, these basic moves are super helpful. What's really a problem that makes fractions difficult? I think the denominator really is the thing that gets in the way very often. Now, suppose we multiply this fraction by 5. If I'm multiplying by 5, remember how this 5 and that 5 can cancel out with each other? But I can't just multiply only that fraction by 5. The only way equations work is if you multiply the whole thing by something, okay? Another important rule. If you're going to do something, it has to apply to the whole equation, especially when we're talking multiplying. So if I do it there, I have to do it here. But watch what happens that's really nice here. I end up with 5 times 3/5 is just 3. So that becomes 3x. Oh, no more fraction. But 5 times -1 becomes minus 5 equals 5 times 14 is going to be 70. Is that okay? Now look what we have. We have an equation without any more fractions, and it's a pretty simple one to backtrack. How nice. So here if I backtrack this, and I add 5 to both sides, I'm left with 3x equals 75. And my last step here would be divide by 3. And I get 75 divided by 3 is 25. And look at that. That's the same exact solution that I got. So look at that really carefully, and that should help you out with dealing with fractions. Look at the denominator and multiply everything in the whole equation by whatever's in that denominator. Go ahead and take a stab at doing this one yourself. Notice, this has parentheses here. So when I multiply by the denominator, it doesn't need to be distributed because it will get distributed later, right? So this one's slightly different than this one. The distribution will happen in another step, not right away. So take a stab at that one. Let's see what you came up with. If we do it this way, then what we're going to do is multiply by 3 there, and then I must multiply by 3 there, because that's what the denominator is. And that's going to give me, this cancels out, and I get just 4 times parentheses x plus 5, and that equals 24. Now here you have a couple choices. This is ready to backtrack. A lot of students automatically think every time we see parentheses, you must distribute. But hold on for a second. There is no variable over here, so distributing actually isn't necessary. We could do this in fewer steps by just backtracking. Notice this says a number plus 5 and then times 4 equals 24. So yes, you could distribute that first, but it will be fewer steps if we do this. We're going to divide by 4 here, because that's being multiplied and that will cancel out. But if I divide by 4, I must divide by 4 on the other side as well. And what we're left with is just x plus 5 over here. And 24 divided by 4 is 6. And you can probably see what the solution is at this point, because you can just do it in your head. You might have just been able to do this in your head too. And again, I want to remind you, I'm totally okay if you get to a point where you're like, I can do this in my head. Just do it. That's fine with me. Then 6 minus 5 is 1. So x equals 1 is my final solution for that equation. One last one before we're done. So to wrap up today, we're going to kind of compare and contrast the two methods we've been learning. A lot of times you can backtrack from the start, or at least maybe after you've done some of the basic moves, then you get to a point where you can backtrack. But this one is backtrackable, but it involves a lot more steps than the ones we've been doing in this lesson. And so we could completely backtrack it, or we could simplify and then apply the basic moves in order to solve it. And I just want you to get in your head thinking, what works when, or what's easier in certain circumstances. So I'll have you pause and try to tackle this one on your own, because you can do that now, and then we'll come together on it. Okay, so let's take a look here. Let's see. Remember that if I'm backtracking, we think of this as my ending number. So I'm just, for now, going to just do it like we've learned to backtrack before. I'm not going to use the basic moves and the balancing idea. Adding 4 was the last thing. So I'm going to do 6 minus 4 equals 2. And then we multiplied by 2 prior to adding 4. So I need to take this 2 and divide it by 2. And that gives me 1. And then what's the next thing I need to undo? I need to undo this subtracting 1, so I need to add 1. So I'm going to take this 1. Don't forget that this is going here. And then I'm going to add 1, and that's going to give me 2 again. And then this is my last thing there, was my first step here, if I think of it as a number trick, is take a number, divide by 3, right? So I need to undo that by multiplying by 3. So it seems like what I get here is 6. Well, that's interesting. My ending number was 6 and my starting number was 6. But here, x equals 6 is our solution. And remember, what we're thinking of it is as we just worked backwards to dig out my starting number. Now let's take a look at it the other way. If I'm simplifying first, then remember, I don't need to do any balancing yet. We're just simplifying. In this case, what that's going to mean is to distribute that 2 across those things. So this becomes 2 2/3 x. I know the x is in the top, but don't forget, with fractions, something in the top could be brought out front, right? And then 2 times -1 is -2, and then we have that plus 4 equals 6. And these minus 2 plus 4 can combine. So I have 2/3 x, negative 2 plus 4 is a positive 2 equals 6. Now we're at the point where we can either backtrack, or if you want, you can apply that fraction thing we talked about. I think I'll do that. I'm going to multiply both sides entirely by 3, because that'll cancel this denominator out. So I need to distribute again though. So this cancels with that, and it leaves just 2x, this 2 and x, and 3 times 2 is plus 6, and that equals 18. And at this point, I'm just going to skip to the solution because we can backtrack it. If I subtract 6, I get 12, and divide by 2, I get x equals 6. And so that ends up being the solution whether we use the one way or the other way. Okay? So we've gone through a lot of thorough ways now that we officially can tackle any equation that might come to us that just has one single variable in it. So that's it for this big lesson. Happy math, and we'll see you next time.